Hello everyone, welcome to Chapter 7. And Chapter 7 we're going to talk about solutions. And so solutions are, usually you think of solutions as liquids, but not always. And solutions are just mixtures, and they're mixtures of two or more substances. And usually, like if you're looking at something, for example, like this particular picture where you are pouring a solid into a liquid, you think of the liquid as the solvent and the solute as the solid or the salt, but it doesn't have to be that. Basically, by definition, the solute is the substance that is in the lesser amount, and the solvent is the whatever you have the most of. So like you could put two liquids together, and then the solvent would be whichever one you had the most of. So they're homogeneous mixtures, which means when you put them together you can't tell them apart anymore. And what is causing this is an attraction between the molecules of the solute and the solvent. And the solvent, which is going to be a larger amount, okay, and the solute, which is going to be present in the smaller amounts. And so the definition of those is that. But you will see that we're going to see quite a few cases where it's going to be the typical solution with the solvent as a liquid and the solute as the solid. So the solute molecules spread evenly throughout the solution. This is a picture of where you put some copper sulfate into a graduated cylinder with water, and if you just leave it there and don't move it, eventually it will spread throughout this solution and become homogeneous, and that is the molecules of the copper and the water will become very evenly mixed. And that is a law of nature, if you will. You can't separate a solution by filtration, but you can separate it by evaporating it. And so if you set a salt water container in the window and let the sun hit it, and so that the water evaporates off, eventually you would lose the water as vapor, and you would be left with the solid salt that you had put in there to begin with. So it's not visible inside this. You're not going to see the little grains of salt in there, but they're there. In the case of copper sulfate, it makes it a little bit easier because copper sulfate, when you put it in water, turns a nice pretty blue color. So as I said, the solutes and solvents can be solids, liquids, or gases. Gas solutions such as air, a gas solution has oxygen as the primary solute, and the solvent is nitrogen, because nitrogen is what we have most of, like 70-something%, and about 21% oxygen in there. And so by our definition, that has to be the solvent and that has to be the solute. You can have gases in a liquid, such as sodas and colas. You can have liquids in a liquid, such as vinegar, where you have acetic acid in water. A solid in water, of course, is what I think of a lot of times, and that's the sodium chloride, the salt water that my mom used to make me gargle with when I was a kid. Solid solutions, a liquid in a solid, like a dental amalgam. You don't see those as much anymore, but that's where you have liquid mercury and you suspend that in solid silver. A solid in a solid is your alloys. A lot of times brass, which is a combination of zinc and copper, which are melted and merged together. So that's a solid in a solid. And when you're done, it's brass and you really can't tell the difference anymore. The universal solvent, we call it, is water. And water is one of the most common in nature. As far as we know, you need water to support life. And so we'll always say that in astrobiology as life as we know it. Water is a polar molecule. And if you remember what that means, it means that you have a partial negative end and a partial positive end to that molecule. And that's due to the fact that it has polar bonds between the oxygen and the hydrogen. Molecules form hydrogen bonds between each other. Okay, so it's important to remember that you've got the oxygen covalently bound to your two hydrogens, which gives this a slightly positive end and a slightly negative end on the side with the oxygens. And if you remember electronegativity and all that, that the oxygen has a lot more electrons coming in, so it's more electronegative, and so it tends to pull all of those electrons towards itself. And so as that electronegative atom, it has this kind of negative. And so if you have another water molecule which also has these slightly positive and negative ends, these two will be attracted to each other, because we know that opposites are attracted to each other, right? So that's how water stays together. And this fact right here, this hydrogen bonding between the molecules and the fact that it's polar, gives it some very interesting properties. When we dissolve a salt such as sodium chloride, and everybody I'm sure knows that that's table salt, they undergo something called hydration. And basically hydration is a word that's kind of like water, hydro. What happens is that you dump the solid in, and you have positive and negative components here. You've got positive sodiums and negative chlorines, and so what the water molecules do, because they have a negative and a positive end, is they will orient around the negative ion with the positive side of the water, and they will orient with the negative side where the oxygen is around the sodium. And they call these spheres of hydration. And so these hydrated ions are surrounding these pieces, these ions, and that's what causes them to disappear into solution, so you can no longer see them. And so the solid sodium chloride, when placed in water, is going to give us sodium ions and chloride ions. One of the big rules in chemistry is like dissolves like. Okay, like dissolves like. And so if you have something that's polar, since water is a polar molecule, then it will dissolve it. If you have something that's nonpolar, then it won't dissolve in water. Okay, and so things that are nonpolar are things like oil. And if you try to put oil in water, it's not going to mix, right? So the polar ionic will mix with a polar solvent such as water. The nonpolar will mix in other nonpolar solvents such as oil in gasoline, for example. So like dissolves like, as I said, and so the polarity of the solute and the solvent must be similar in order for them to mix. And so if they're not similar, then they will form two separate layers. Okay, so let's do some learning checks on this. Identify the solute in each of the following solutions. So remember the rule. The rule is that whichever one is the bigger is the solvent, okay? And so whatever's in a lesser amount is solute. This first one may be trying to trick you a little bit. We know the specific gravity of water is 1, and so 100 milliliters is the same thing as 100 grams of water. So which one is the solute here? Should be the 2 grams of sugar. If you've got 60 milliliters of ethyl alcohol and 30 milliliters of methyl alcohol, which one is the solute? Well, it's the one that's the smallest, so it's going to be the 30. Okay, so again, you just kind of go through those and figure out which is which. Give you a minute. So we already said the 2 grams is the solute. The methyl alcohol is the solute in the second one. The solute 1.5 grams in 55 milliliters would be the salt, would be the solute. And then between the 200 milliliters of oxygen and 800 milliliters of nitrogen, the solute is going to be oxygen. When you add lithium chloride to water, it will dissolve because the lithium ions are attracted to the oxygen or the hydrogen atoms. So the oxygen has a partial negative charge, the hydrogen has a partial positive charge. So if lithium is a positive, it's going to be attracted to what? Right, the negative. And so if lithium's attracted to the negative, then the negative chloride is going to have to be attracted to the positive hydrogen, because opposites attract. Which of the following solutes will dissolve in water and why? Okay, so these you need to look and see what you think. Sodium sulfate is an ionic compound. Okay, and by definition, an ionic compound is going to form ions when it's put in water, right? Gasoline is nonpolar. Will that dissolve in water? No, because it's nonpolar and it has to be polar or ionic to dissolve. What about I2? Is that polar? What about hydrochloric acid? Will that dissolve? I2 will not dissolve, but hydrochloric acid will dissolve. And so it gets down to the polarity or nonpolar, right? Most polar ionics are going to dissolve. There are a few that won't, but that's another topic. And that's the end of section 7.1, and I will see you again for 7.2.